We're going to look at another example of finding the intercepts and symmetry tests given an equation. So let's say I have y equals x squared plus 4. Okay. Let's start off by finding our intercepts. So let's look for our x-intercepts. Remember, this means I want to take y and set it equal to 0. So doing that, I've got 0 equals x squared plus 4. And just because it's more comfortable, I'm going to flip this around and have x squared plus 4 equals 0. Okay, we're used to having our variables on the left-hand side, so you're more than okay to do that. Now I need to continue solving for x, so I need to subtract 4 from both sides. That adds up to 0, so now I'm looking at x squared equals negative 4. Okay, some of you might see the problem already, but if not, to continue solving for x, I need the square root method. So that means I'm going to put a square root on both sides, equals plus or minus the square root of negative 4. The entire point of square root method is that the radical gets rid of my exponent, and now I just have x equals plus or minus. Now I need to do some simplifying here. I've got a negative number underneath my square root. We don't like that. We pull that out as an I in front. And I know the square root of 4, that's 2. Okay, so x equals plus or minus 2i. If you want to see this worked out, this is what you're doing. You can factor the negative 1 away from the 4, so you have negative 1 times 4. Because you have multiplication in the middle, you can break up the square root, so you have the square root of negative 1 times the square root of 4. The square root of negative 1 is the imaginary unit, I, and the square root of 4 is 2. So here I'm looking at plus or minus 2i. Now if you think about graphing, this is my x-axis, this is my y-axis. I don't have anywhere to plot 2i. And because of that, we can say that there are no x-intercepts. Okay, so we do want a statement and not just solving for x. You want to be able to tell your instructor you understood what happened here. So because it's imaginary, it's telling me that there is no crossing here along this line. Okay, that's my x-axis, my x-intercepts. Let's find the y-intercepts. And remember, for my y-intercepts, I want to take x and plug in 0 for that. Move my paper up. So now, my equation is y equals 0 squared plus 4. Simplifying that down, I have y equals 4. So I don't have an imaginary number. That means I am crossing the y-axis, so I have a y-intercept. And remember, that is a point. So my y-intercept is the point 0, 4. Okay. So I only have one intercept. Now we need to test for symmetry. So symmetry tests. We do have 3 of them. Remember, for our x-axis, symmetry, we want to take y and plug in negative y. So my original equation was y equals x squared plus 4. I have negative y, plugging in now, equals x squared plus 4. Now I plug it in parentheses out of habit, but I don't actually need them on that y, so I have negative y equals x squared plus 4. This is not fully simplified though, because I have something over here in front of y. So to get rid of that, I'm going to divide everything by negative 1. And I can do that because I have my equal sign. All it does is change all of my signs over. So now I have y equals negative x squared minus 4. Now, remember, I'm not solving for anything else. I want to plug in my negative y and then just simplify everything as much as I can. Now, looking back at my equations, I have y equals x squared plus 4 and y equals negative x squared minus 4. So the equations are not equal. It is not symmetric across the x. You do want to have some kind of written statement there explaining that you understood what you just did. This is your result. Okay, so you do need to identify that it is not symmetric. Now I can test for my y-axis symmetry. That is, I'm going to take x and plug in negative x. So my original equation was y equals x squared plus 4. Plugging in negative x at negative x squared plus 4. And we saw in a previous video that negative x times negative x is positive x squared. So y equals x squared plus 4. I'm fully simplified, so I can compare my equations. I have x squared plus 4 and x squared plus 4. The equations are equal. So it is symmetric across the y-axis. We have one more test for symmetry, and that is symmetry across the origin. And that means I'm going to do y equals negative y and x equals negative x at the exact same time. Okay, so my equation is y equals x squared plus 4. And making these replacements, let's do it in blue. I've got negative y equals negative x squared plus 4. Again, I don't need these parentheses around my negative y, so I have negative y equals, we already know that negative x squared is positive x squared plus 4. And one more time, I don't want this negative right here. I can divide it out using negative 1. So I am left with y equals negative x squared minus 4. Now that I'm fully simplified, I just need to compare my equations. They are not the same thing. So I can say the equations are not equal. So it is not symmetric across the origin. I'm going to box this in as my result. And I'm done.